Hello everyone, welcome back to today's video. We are going to talk about another lead code problem step by step so that you can strengthen your coding skills. Today we are going to talk about this very old and very important and this question is very asked in a lot of interviews as well, which is n queens. It has two parts. Sometimes there are two parts in this question, and queens one and queens two. Both of the approach has same logic. I'll discuss like both of the question today, but let's talk about this first. In this question, we have been given a chessboard of n by n, and we have to place n queens in the chessboard such that no two queens attack each other. And we have to output how many number of those possible arrangement can we found from this question for this question. So in this example, as we can see, like for 4 into 4, for the value of n as 4, we can place like in these two formats. We can place the queens in these two formats. So there are two distinct solutions to the f4 queens for puzzle as shown. For n equal to 1, the output is obviously 1. So the value of n can go from 1 to 9. And we have to find the how many number of these possible arrangement can be there in which no queens attack each other. So how we are going to solve this question? So this question, first of all, what we have to understand from this question is the value of 9 is very small, which is like going from 1 to 9. So in this case, when the value of n is very small, the first thing that should come in our mind is we can find all the possible solutions. All we can like out check all the possible solution where we can put queen and check how many number of possible distinct solution are there, and it will be under the time complexity, which will be under the time limit that we have been given in the question, because that's the first hint that we have to that is given in the question, that we can use backtracking concept approach backtracking approach to solve this question. In backtracking, basically what we do is basically like we are checking all the possible solution which is possible in the question, and we are going to count how many possible answers are there and the number of distinct solution would be possible. So for this question, we have initial input n, and we have initialized a 2D vector boolean with 0 here, and we have initialized a variable answer. This answer value is basically going to count how many arrangement we have found, and we are going to return that answer as our final answer. So here I've written a function which is taking q, and q is basically this, and I have given the address of the answer because I want to when I'm checking the number of possible arrangement, I'm going to increase this answer the answer value the as a pointer as an address, so that it should take the we it should update the same answer variable that we have initially. That's why I'm giving the address of this variable, and I initialize a variable as 0 as well. The reason being why I'm going to initialize the value as 0. This 0 is basically representing how many queens we have placed till now. Like we can, first of all, we can place only one queen in each row. So how many rows we have gone and placed the queens in that rows. So this function is that. Now what we are going to do, we are going to check for each queen, we are going to check each cell of that row and we are going to place that queen in that cell, and we are going to go to the next uh, queen as well, and we are going to check where we can put the next queen so that the it's not going to get attacked by the previous queen. So in this way, we are going to check, is there any, like, for this possibility, is there any way, or is there any possible solution so that we can put all the queens, all four queens, and we will have all the four queens are not cutting each other, or all of them are safe. And if we have that, then we are going to increase the answer value as one. So this is the first if statement. This is what it's representing. So you can see here, this if statement is basically if iteration like this, iteration value is equals and means all the queens are placed, and it means like we can increase the value of answer by one because we have found a one correct solution, and then we are going to return. Now, how we are this is the first if statement, which is representing basically that. Now, this for loop is basically checking for each of the cell. Like for each queen, we can go from cell 0 to cell n minus 1, and we are going to place each queen in. We are going to check whether we can place that queen inside that cell or not. So this safe function is basically going to give our output as true or false. True when we can like place like no queens are attacking in that cell. The no previous queens that are placed in the previous cells or previous rows are attacking the current cell. In that case, the save function is going to return true. So if that is true, then we are going to place queen in that cell by setting that value as true, as q itr I as true. And then we are going to again call the function by increasing the uh, this itr value as by increasing that value by one, because this time it's basically telling us like now one queen is placed. Now we can go on to the next queen. Now, what this backtracking concept is, now what we are going to do, like if that works, then it's going to you go again like using a recursion function and going to check the next queen. If that doesn't work, then we are going to take the queen from that cell and going to put into the next cell. That's why I've taken q itr I as false to represent like now we cannot place our queen in that. We are going to take our queen from this section and we with this cell, and we are going to try on the other cell. That's how we are trying each cell one by one. By putting the queen, checking for the next queen. If it works, if it's good, then we are going to increase the answer value by one. If it doesn't, then we are going to try the next box or cell. So this is the flow of this question, workflow of this part of the function. Now we just have to write our save function, which is basically checking if that cell, whether that we can put the queen in that cell or not, such that it's not getting cut by or attacked by the previous queen that we already have in the previous rows. So for that function, we have I provided input as q. First of all, q is the current position of the chessboard, or and by n chessboard, where we have already placed q, or where we cannot place queen again. N is basically the number of n into n, the number of queens that we have, total number of queens. ITR is basically the number of queens that are already placed, and the I vector, I point variable. I vector is I pointer variable is basically showing the current position that we have to check with at this point. ITR is basically the current location of the queen, like ITR. That's why these four variables have taken into the function. Now this bool save function is checking three possible ways. Like from the current position that we want to put queen on, we are going to go uh, up, vertically up, uh, then diagonally towards, if the north is if the north side direction is towards upward, then it's checking the north direction, northeast direction, and northwest direction, because these are the three possible ways queen can cut the other queens. So basically, it's checking there is no queen along the north, there is no queen along the northeast, and there is no queen along the northwest. So this is what these three for loops are basically doing. So this for loop is basically going from I equal to 0 to row and checking for this column all the if all of them are false or not, or true. If any of these are true, means there is a queen there, so we have to return false. And then it's going diagonally northeast and diagonally northwest. If any of these values are true, it means queen is there, so we are going to return false. Otherwise, we are going to return true. So this was a very straightforward solution of this question. It just looks a bit difficult, but if you are taking the right approach, then backtracking question, I honestly feel it's very easy if you understand what it's doing the behind the back, basically. Now there is another type in this question, in which you might have to output the position as well. Like in this question, queen and queens is the same. In here, you just have to output the position. Here, like if 4 by 4, you have to position dot to, means there is nothing, q dot dot or dot q in this way. What is the, like you have to output this as a vector of strings, basically, or the vector of character, or whatever. So in this way, you might have to output each of the possible solutions. So for that as well, it's the same, to be honest. It's just same. I've just written one more function here, which is for the creating the board. If we found the solution, you can have a look at this solution. Otherwise, like there is nothing new. What I have done, what I was checking earlier was when we can place the queen. At that time, I was putting that cell as true. If we are not placing the queen, then as false. So instead of true and false, what I'm just doing is I'm just putting a dot or a q. That's it. That's what this construct board function is doing. Otherwise, it's pretty much the same. So these are the two and queens question. Both of them are same. Only one more function you might have to write for solving this question, for putting for outputting in the possible solution in the form of string, a vector of string. So this is it for this question. If you found this video very helpful, don't forget to like, subscribe, and drop a comment with your thoughts. And if you have any questions, that's all. Thank you so much for today. Have a nice day.